March 1942, Provincetown, Massachusetts. A Coast Guard patrol boat was pinned on a sandbar in weather that made rescue boats turn back. 60-knot wind, cold rain, white water breaking hard enough to erase the line between beach and ocean. 7 men were trapped out there. And then something ridiculous rolled toward the surf. It had 6 truck wheels, a blunt steel nose, a boat hull wrapped around a military cargo truck, and a propeller under the rear like somebody had built it during an argument between a mechanic and a shipyard. The Army had already looked at this machine and rejected it. Too strange, too thin-skinned, too slow in the water, too awkward on land. Not enough truck to be trusted. Not enough boat to be believed. But that afternoon, while proper rescue craft stayed helpless in the storm, the ugly truck drove into the Atlantic. They climbed through the waves, it reached the stranded men, and it brought all 7 back alive. That was the day the most mocked vehicle in the American war machine stopped being a joke. Its official name was DUKW. The soldiers called it the Duck. And by the time the war was over, more than 21,000 of them would be built. They would carry ammunition onto invasion beaches. They would haul wounded men out of surf. They would turn open water into a road. They would keep armies supplied in places where a normal truck would drown, and a boat would become useless the second it touched sand. But the strangest part is this. The Duck did not win its war because it was powerful. It won because it removed one invisible weakness from every invasion plan. The moment when cargo had to stop moving. To understand why that mattered, you have to forget the movie version of amphibious warfare for a minute. Forget the landing craft doors dropping. Forget the first wave running through smoke. Forget the tanks crawling out of the surf. Those moments were terrifying, but they were not the whole problem. The real problem began after the beach was taken. Because an army does not live on courage, it lives on tonnage. Every rifle needed ammunition. Every radio needed batteries. Every field kitchen needed food. Every medic needed plasma, bandages, morphine, litters. Every Sherman tank needed fuel in amounts so obscene that a single breakthrough could drink a beach dry in hours. And in 1942, the supply chain for an invasion beach was a nightmare made of handoffs. A ship anchored offshore. Cargo moved from the ship into a landing craft. The landing craft fought its way to the beach. Men unloaded crates into the surf. Trucks tried to reach the waterline without sinking in sand. The cargo was loaded again. Then the truck finally moved inland. Ship to boat, boat to beach, beach to truck, truck to dump. Every transfer cost time. Every pause created a target. Every stuck wheel, broken ramp, swamped craft, or confused traffic lanes slowed the whole army behind it. The enemy did not have to destroy every crate. He only had to make the beach choke. That was the problem the DUKW was built to solve. Not by looking heroic, by refusing to stop. The men behind it were not famous battlefield commanders. They were yacht designers, truck engineers, and problem solvers who understood something the procurement system did not want to hear. A landing beach was not really land, and it was not really sea. It was the broken place between both. That place needed its own machine. At Sparkman and Stevens, a yacht design firm better known for clean hulls than combat vehicles, Rod Stevens Jr. and Dennis Polston helped shape the water side of the answer. At General Motors and Yellow Truck and Coach, engineers took the proven bones of a 6x6 military cargo truck and asked a dangerous question. What if the truck did not stop at the shoreline?
Frank Spear, an MIT engineer working inside that amphibious problem, pushed one of the small details that would become one of the Duck's quiet miracles. A tire pressure system the driver could control from inside the cab. It sounds boring until you picture the beach. Fully inflated tires were good on roads. Soft tires were better on sand. A normal driver had to stop, climb out, and adjust them by hand. The Duck driver could change pressure while the vehicle was moving from road to surf to soft beach and back again. That was not a luxury. That was survival. Because beach sand does not care how patriotic a truck is. It swallows anything that puts its weight in the wrong place. The final machine looked wrong from every angle. 31 feet long, more than 13,000 pounds empty, 6 driven wheels, a welded steel hull thin enough to remind every crewman that this was not armor, a propeller and rudder underneath, bilge pumps to fight leaks, a cargo bed large enough for about 5,000 pounds of supplies or 24 troops in a pinch. On a road, it could run like a truck. In water, it crawled like a stubborn little boat. On sand, it could lower its tires and spread its weight. It was not elegant. It was not fast in any one world. Its genius was that it belonged to 2 worlds badly enough to connect them. And that was exactly why the armed services did not want it at first. To a truck officer, it looked like a ruined truck. To a boat officer, it looked like a joke boat. To an infantry officer, it looked like a large, unarmored target. The hull was not thick enough to stop serious fire. The water speed was unimpressive. The shape was awkward. The idea sounded like a compromise, and every old soldier had seen compromises die the first time theory met weather. The skeptics had a point. A DUKW overloaded by a careless crew could become dangerous. A driver who understood highways but not surf could kill men. A commander who treated it like an assault boat or an armored vehicle would discover its limits in the cruelest possible way. The Duck was not magic. It was a tool. And like every good tool, it could be deadly when used stupidly. That is why the Provincetown rescue mattered. It did not prove the Duck was invincible. It proved something more useful. It proved that in the exact zone where ordinary systems failed, this ugly machine could keep moving. That was enough to crack the door open. Production followed. Training followed. And then, the war gave the Duck the test no engineer could create on a drawing board: an invasion beach. The first lessons were not clean. Men had to learn that driving a DUKW was not the same as driving a truck with a funny body. A good Duck driver had to read surf, sand, tide, current, load balance, and engine strain all at once. He had to know when the propeller mattered, when the wheels mattered, and when the vehicle needed both. He had to understand that the cargo behind him might be the difference between a rifle company holding a line and that same line folding before sunset. A crate of ammunition did not look dramatic until it arrived 3 minutes late. A fuel drum did not look heroic until a tank stopped moving because nobody brought it forward. A surgical kit did not look like a weapon until a wounded man lived because it reached the aid station before shock took him. That was the world the Duck entered, not the world of glorious machines, the world of late things, the world where almost every disaster begins with somebody saying the supplies are still on the beach. By 1944, the Allies were preparing for the largest amphibious invasion in history: Normandy. 5 assault beaches, thousands of ships and landing craft, airborne troops dropped behind the coast, artificial harbors dragged across the channel in pieces. A whole invasion built on the belief that men, vehicles, fuel, food, and ammunition
could be pushed through open beaches faster than Germany could throw them back into the sea. That belief had one terrifying weakness. There was no deep-water port in the first hours. The Allies could land soldiers, they could land tanks, but after that, every day became a race between supply and collapse. And then, less than 2 weeks after D-Day, the weather turned. A violent Channel storm hit the Normandy beaches in June 1944. The American artificial harbor off Omaha was wrecked. Landing operations were disrupted, ships rolled, causeways twisted, small craft were smashed or scattered. The Beachhead had survived German fire. Now it had to survive the sea, and this is where the duck's real value became impossible to ignore. Because a harbor is a place where cargo changes worlds, ship world to land world. The DUKW was a harbor with an engine. It could be loaded offshore. It could nose down a ramp into water. It could churn through waves. It could crawl onto sand. It could keep driving inland to a supply point without unloading once. That was the secret. Not armor, not speed, not a gun. Continuity. The cargo did not have to stop breathing. Every time a crate avoided one transfer, the whole army gained time. Every time a fuel load bypassed a jammed beach lane, a tank company gained distance. Every time medical supplies went straight from ship to shore to aid station, men who would have waited survived. The duck's greatest trick was not crossing water. It was crossing the handoff. That is why soldiers who had laughed at it began to depend on it. At Normandy, in Italy, in the Pacific, and later in Korea, DUKWs became part of the invisible machinery that made visible victory possible. You could watch a tank advance and understand its purpose immediately. You could watch a fighter plane scream overhead and feel its power in your chest. But a duck full of ration boxes, artillery shells, or jerry cans looked ordinary, almost disappointing. Until you understood that the army ahead of it was eating, shooting, driving, and surviving because that ugly cargo kept arriving. The Germans had built walls. The Japanese had built island defenses. Terrain itself built worse defenses than either of them. Surf, mud, coral, sand, flooded roads, broken ports, shattered causeways. The duck did not defeat those obstacles through brute force. It refused to respect their categories. Land? Sea? It answered yes. In the Pacific, where every island was its own logistics trap, that answer mattered. A beach could be narrow, a reef could be treacherous, a pier could be gone, and supplies still had to move. In Europe, where the Allied armies raced inland faster than ports could be opened, the same answer mattered. The invasion did not end when boots touched France. That was only the first sentence. The campaign continued because tonnage kept crossing the beach. And much of that tonnage crossed in vehicles that looked like they should not have worked. The nickname made it sound harmless. Duck, almost cute. But the official code was not a joke. D for the 1942 production series, U for utility, K for all-wheel drive, W for tandem rear axles. There was nothing poetic in it, just industrial language for a machine built under pressure. And maybe that is why the DUKW is so easy to underestimate. It did not have the romance of a Spitfire. It did not have the menace of a Tiger tank. It did not have the mythic simplicity of the Jeep. It had pumps, tires, a propeller shaft, a thin hull, a cargo bed, a driver watching the waves and praying the load stayed balanced. But war is often decided by machines like that. Machines that do not look like symbols.
Machines that do the unglamorous things so relentlessly that the glamorous things remain possible. Frank Spear did not become a household name. Rod Stevens Jr. did not become a monument. Dennis Paulston was not turned into a legend on recruiting posters. Most of the men who designed the Duck went back into the world of engineering after the war. The vehicle they helped create scattered into surplus yards, foreign armies, rescue stations, research work, and eventually even tourist fleets that carried families across lakes with the same amphibious trick once used to feed armies. That afterlife almost makes the machine seem gentle. But it was born from a brutal question. How do you keep an army alive when there is no road, no pier, no harbor, and no time? The DUKW answered with movement. More than 21,000 were built before production ended in 1945. They served beyond the war. They were used again in Korea. They influenced later amphibious cargo vehicles. Their tire pressure concept became normal enough that people stopped remembering how radical it had been. That is what happens to successful engineering. First it is ridiculous, then it is dangerous, then it is obvious. And once it becomes obvious, history forgets the people who had to fight for it. But the story of the Duck should not be remembered as a cute invention story. It is sharper than that. It is a story about institutions failing to recognize a machine because it did not fit their categories. It is a story about an invasion system discovering that the deadliest weakness on a beach is not always enemy fire. Sometimes it is a stalled crate. Sometimes it is a truck stuck 20 feet from the tide line. Sometimes it is a wounded man waiting for supplies that are still on a ship. The DUKW did not solve war. It solved that moment. The break between water and land. The pause where armies can die. And that is why the ugly truck that drove into the storm off Provincetown deserves to be remembered. Not because it was beautiful, not because it was loved, not because it looked like the future, but because when the beach tried to stop the army, the Duck kept rolling. When the sea tried to keep supplies offshore, the Duck carried them through. When the road ended, it made another one. The most important vehicle on a battlefield is not always the one with the thickest armor or the biggest gun. Sometimes it is the one that refuses to choose between land and sea.